Hello guys. So in this video I'll be showcasing the new terrain prop generation system that I've implemented in my Unity voxel terrain generator. So this allows me to generate these trees as you can see. Now these trees are originally generated on the GPU, but then I do a CPU asynchronous readback to be able to generate these on the CPU as actual game objects with colliders and such. Now not all props are generated like this, and only the ones close to the player are actually read back from the GPU and generated as game objects. As you can see, the ones further away are actually billboarded. Now, this billboarding system works based on a world segmentation system that I've implemented just for this feature. So I can demonstrate this by going in my voxel props or voxel segments script and debug the world segments. So as you can see, I have many world segments that span many chunks, and these world segments are fixed size, and as you can see, only the ones that are in green are containing the voxel props, the game object voxel props. Everything else is billboarded. Now these billboarded voxel props are GPU instanced in that they use GPU indirect instancing to be able to render a lot of them procedurally without having any hit on performance. And as you can see, they can cast shadows on their own, and they always face the camera. So if you were to look at from the perspective of the user, they don't look that different from other trees. But again, when you get close to them, you can truly see that they're flat and they're billboarded. So these billboards actually contain albedo, normal, and mask map data that I capture at the start of the game, and this is actually handled by my voxel props rendering code over here. This captures three textures, as I said, the albedo, the normal map, and mask map data for each variant, for each prop type, and stores it in a texture array, which is then sampled in a custom shader graph shader. And this is the actual function that renders all the billboards automatically using the graphics.renderMeshIndirect function. Since this is all on the GPU, this allows me to do frustum culling on the GPU. So as you can see, I have all my billboards over there. But if I look away, the billboards dynamically pop in and pop out based on the camera's view. Now, my implementation right now is very naive in that it only uses a dot product from the camera vector to the normalized difference from the actual prop and the camera position. So it's not actually using frustum culling, but for now it works pretty nicely for such a simple implementation. And I'm eventually going to add full-on voxel occlusion and voxel occlusion culling directly, so that if you get close to a chunk that hides all these props, they would automatically get hidden away, but that is obviously a lot harder to implement. And this instancing system doesn't only apply to billboards, in that these little rocks and pebbles are actually instanced as well, but they use a custom mesh, and all of this can be tuned and tweaked in my custom scripting object system. So I can tweak the number of pixels for the billboards. I can even enable if they should look at the camera directly or not. So as you can see, if I disable that functionality, the billboards would look at the camera in all directions, which doesn't really make sense for these types of trees, since trees don't normally look at the camera like that. But it doesn't really matter since the user is going to be very far away. So it's basically flat, but it only happens for, just added it as convenience sake. And you can also disable shadow casting for these props. And I also implement mip mapping. So when I get away, I'm able to see that the trees or the props just become simple pixels, and that's because the mip map at that layer is just a simple pixel, which takes the size of the whole quad. So a lot of resolution is lost, but that's the point of mip mapping, just to improve performance. And yeah, thank you for watching. See you in the next one.